Okay, so this is textbook chapter 6, question 28. And you have time that it takes to service a car is exponential random variable with rate 1. So you have two customers, AJ and MJ. So let's define X to be the service time for AJ and Y to be the service time for MJ. Both of these are exponential 1. So what you know is Fx is e to the negative x, and Fy is e to the negative y. Okay, so this is starting point. So question 1 is asking you that if AJ brings his car in at time 0 and MJ brings her cars in at time t, what's the probability that MJ's car is ready before AJ's car? So that's essentially asking you to get the probability that the service time for MJ minus the service time for X, which is AJ, actually should be greater than t. Okay, because X starts at time 0, Y starts at time t, but you're asking to get probability that MJ's car is going to be ready earlier. So this is the event that you're trying to compute the probability. So this again is a double integral of the joint. Oops. Joint. Okay. All right. So 2 parts. Whenever you're doing double integral exercise, you need to find the joint and you need to find this region. So joint, because they're independent, so the joint will be the product, the marginal, which becomes e to the x, negative x, and e to the negative y. Okay, and second, this region, always sketch. This is x, this is y, 0. So say this is t. So you're having this line, because y is greater than x plus t. So you are trying to get this part. All right. So if you solve this too, you can actually keep doing your integral. So over here, I'm going to do double integral e to x, e to y. I decide to do dy first and dx. So if I do dy, this is the lower bound, and you have x plus t to infinity. So, yeah. And then for dx, it's just going to be from 0 to infinity. Okay. Sorry about the eraser. Worked. Yeah. Okay. So I won't show you the derivation further on, but once you derive it, calculate it, I should say, you're going to get this. Okay. So this is first part. Second part is asking a different question. It's asking that if both cars are brought in at time 0 and with work starting on MJ's cars only when AJ's car is ready and has been completely serviced, what's the probability that MJ's car is ready before time 2? Okay, so this is they're brought in at the same time, but you're going to do AJ's cars first, and once it's done, you're going to do MJ's car. So essentially, you are trying to integrate. So I should say, you should start writing the event first. So that's probability of the sum of these two is less than 2, okay? Because you service AJ's car first, which is going to take X time, and then you're going to do it MJ for second. Now you want both of this to be done by 2, so you're doing the sum of these two. So in terms of double integral, okay. All right, so this again, the joint, we did it earlier already. It's the product of these two, okay? And so that's solved. And then for this, this graph, it's going to be 0 to 2 to 2, and it's this particular region, okay, the triangle. So once you get this ready, so I'm doing dx first and then dy. If you do dx first, then it's going to be from 0 to 2 minus y, because that's, say if you rewrite this part, this x is smaller than y, 2 minus y, okay? And then for y, it's going to from 0 to 2. So if you do that integral, it's going to be 1 minus 3 e to the negative 2. Okay? All right, that's it.